This question was asked in the GATE Physics paper 2020. This is a numerical answer type question having 2 marks, and the topic of the question is solid state physics. The question is, consider a simple cubic monatomic previous lattice which has a basis with vectors r1 vector equals to 0 and the second basis r2 vector is a by 4 times x cap plus y cap plus z cap, where a is the lattice parameter. The Bragg reflection is observed due to the change in the wave vector between the incident and the scattered beam as given by capital K vector equals to n1 times g1 vector plus n2 times g2 vector plus n3 times g3 vector, where n1, n2, n3 are the integers and g1, g2 and g3 vectors are primitive reciprocal lattice vectors. For n1 equals to 3, n2 equals to 3 and n3 equals to 2, the geometrical structure factor is, so we have to find the geometrical structure factor for this kind of lattice with this given n1, n2 and n3 values. Let us see how to solve this problem. For a simple cubic monoatomic Bravais lattice which has a basis with vectors r1 vector equals to 0 and r2 vector equals to a by 4 times x cap plus y cap plus z cap, where a is the lattice parameter. So the basis atoms are lying at the points 0, 0, 0 and a 1 by 4, 1 by 4, 1 by 4. According to the question, the capital K vector is basically change in the wave vectors of the incident and scattered X-ray beam, and that is also given by n1 times g1 vector plus n2 times g2 vector plus n3 times g3 vector. Here n1, n2, n3 are the integers. Those are analogous to the Miller indices, that is HKL, and g1 vector, g2 vector and g3 vector are the primitive translational vectors in reciprocal space. So those are reciprocal lattice vectors, and that is usually denoted by A star vector, B star vector and C star vector. Now the geometrical structure factor S as a function of n1, n2 and n3 is expressed by S as a function of n1, n2 and n3 is equals to sum over j exponential of 2 pi iota times xj times n1 plus yj times n2 plus zj times n3. Here the sum is over the basis and xj, yj, zj is the coordinates of the jth basis. Now we have two bases in our system. The basis atoms are available at 0, 0, 0 and 1 by 4, 1 by 4, 1 by 4. Hence, j will be having values 1 and 2 only, and for the j values x1, y1 and z1 will have the value 0, 0, 0 and x2, y2, z2 will be 1 by 4, 1 by 4, 1 by 4. So we will use these values in the expression of the structure factor. So we will get S as a function of n1, n2 and n3 will be sum of j, and j value will take 1 and 2 exponential of 2 pi iota xj n1 plus yj n2 plus zj n3. So we will have exponential of 2 pi iota 0 into n1 plus 0 into n2 plus 0 into n3, because for the first basis the coordinate is 0, 0, 0, and for the second basis we will have exponential of 2 pi iota times 1 by 4 times n1 plus 1 by 4 times n2 plus 1 by 4 times n3. So we are having that the structure factor S is equals to exponential of 2 pi iota times 0 plus exponential of 2 pi iota by 4 times n1 plus n2 plus n3. So this term will give exponential of 0, that is 1, and the second term will give exponential of pi iota by 2 times n1 plus n2 plus n3. Now according to the question, n1 equals to 3, n2 equals to 3 and n3 equals to 2. So the geometrical structure factor is S as a function of 3, 3, 2 equals to 1 plus exponential of pi iota by 2 times 3 plus 3 plus 2. So this will give exponential of 4 pi iota. So we will have the structure factor 1 plus exponential of 4 pi iota. Now, exponential of 4 pi iota is basically 1. So, we will have the structure factor 1 plus 1, that is 2. So, the geometrical structure factor for n1 equals to 3, n2 equals to 3 and n3 equals to 2 is 2. So, we solved this problem and we found that the structure factor for the simple cubic monatomic Brebbius lattice with 2 bases is 2 for this given n1, n2 and n3 values.